Thank you for being here. My name's Alex. I'm here to talk to you about building sovereign banks with Fedimint. OK, so as Bitcoiners, typically, we love banks. But just kidding, we hate banks. Banks used to be great then everything changed when the surveillance state attacked. I'm here to make an argument that the core of banking is actually a very fundamental, amazing innovation in personal finance that we can make great by solving the problems of. So overview of today, some background. We're going to talk about how banks went wrong. We're going to talk about the innovation of ecash. What is ecash? We're going to talk about Fedimint. And then if there's time, we're going to have about a 20-minute workshop that's speed-run. You guys are going to have time to follow along, but hopefully I'll be able to show you how to build a wallet from start to finish in like roughly 20 minutes. Cool. So part 0, pre-cash and banks. We're going to talk about gold and banknotes and pre-digital banks. First, the OG of money. So what was money back in the day? Well, we used gold. Gold was an incredible innovation and because of its money properties. Gold has all of the great properties that we care about when using a good money, and it's been the GOAT for 9,000 years. Since Mesopotamia, we've been using gold for money. So how did a payment work in a gold money world? Well, a payment's pretty simple. If Alice wants to pay Bob, Alice pays Bob a pound of gold, and then the payment is settled. But this has some obvious problems. This is not a very safe transaction. If you're carrying around bars of gold to pay people, you can get whacked and your gold can get stolen. And also, it's really heavy. It's really inconvenient to carry around your gold, obviously. So we have to come up with a better solution. So how can we protect our gold? What was the first innovation? Well, the first innovation was banks. We have banks, and how this works is that the users would deposit their gold into a bank, and the bank will invest in security once for everybody. And then you can settle payments out of band without having to go to the bank every time. So banks protect the gold. They invest in security once, and you can make payments without physically moving your gold. And this is cool. So how does a payment work in a bank and notes kind of world? Well, first, Alice is going to deposit 1 pound of gold into the bank. Then the bank is going to respond by giving Alice a note that's worth that 1 pound of gold, a voucher for that 1 pound of gold. Then if Alice wants to make a payment to Bob, she's going to hand Bob the voucher. And this is effectively changing the custody of that gold from Alice to Bob. So now Bob can control that gold. And if Bob wants to withdraw the gold from the bank, he can go back to the bank and he can get the pound of gold. Pretty straightforward, pretty standard. This is super cool. We get some awesome properties with our bank just in this very primitive, archaic system. We have reduced friction in our payments. We actually have really good privacy in our payments because you could pay somebody out of band outside of that bank a bunch of different times, and only the final person that's withdrawing from the bank reveals their identity to the bank. So we have some amazing payment properties already. And lastly, for the users, it's much easier to protect the banknote than it is to protect the gold itself. You can hide it, you can conceal it, it's light, it's portable. So we have a much better payment system. So we fixed the money, right? We have no more problems. We no longer have to innovate. Well, of course, we have a couple of other things to overcome. First is globalization, and second is the internet with digital payments. There is a logistical component to paying people around the world that banknotes are not good enough for. And with the internet, you can't just send these papers over the internet. So what do? So we entered the digital world with banks. We need digital payments. How is this going to work in a digital-first world? So let's talk about what does banking look like in a digital world. It starts the same way as the not digital bank. Alice is going to give the bank $10 of gold, the pound of gold, or just $10 of gold, or banknotes. But instead of returning a dollar bill, the bank is going to start a ledger. And it's going to record Alice's identity and credits Alice's account $10. And this is all digital now. So now when Alice wants to pay Bob, she can't just go pay Bob. She has to go ask the bank to pay Bob. This is materially different than a note-first world where Alice can unilaterally pay Bob. So Alice needs to ask the bank to pay Bob. Now the bank updates the ledger to add money into Bob's account. The bank has to know Bob's identity. And then, yeah, now Bob has the money. Can anybody think of a problem introduced with this new digital system? Yes. Yeah, huge. Yeah, so now the bank has the onus of keeping track of the identity of its users. Just because we made things digital and started keeping track of things on a ledger with accounts, we now have the bank forced to hold this responsibility of keeping identity straight. And yeah, among that, so first, yeah, the bank must connect users to accounts, individuals to accounts. The bank also just sees every payment now. Every payment goes to the bank. We no longer have this awesome property of having multiple payments before the bank sees it. So the bank sees every payment. The banks must connect users to accounts. The bank is now carries the onus of personally fighting fraudulent payments. Before, it's just whoever had the bill was able to get the money from the bank. So long as the note was valid, the bank could pay them. But now the bank must have to fight fraudulent transactions. And lastly, the bank can cheat easily, trivially. They can deduct money from individuals' accounts if they don't like them. All right, that's the history of banking in like 5 minutes. Moving on, ecash. So what is ecash? Let's talk about the history of ecash and the innovation that David Chaum invented back in the day. So in 1982, a brilliant computer scientist by the name of David Chaum comes out with a paper called Blind Signatures for Untraceable Payments. He described a new electronic payment system. And also he described an automation, or he described in the paper that automation of the way we pay for goods and services is already underway, describing exactly what we just talked about. And he notes in the paper that this has a substantial impact on personal privacy. Even David Chaum in the 80s realized that the digitization of our banks compromised personal privacy. So we invented something called Chaumian ecash, what we call today Chaumian ecash. And this is, yeah, the new electronic payment system. The core innovation in his paper was a new cryptographic primitive called blind signing. And then with this blind signing, he created a company called DigiCash, which, if you're familiar with your Bitcoin history, this is one of the noted precursors to Bitcoin for digital cash. So what is this blinded signing? This is the crux of how ecash works. So we'll spend a little bit of time on this. So ecash works by, it's a 3-step process. The first step is the user will have a secret message and seal it inside of a carbon copy envelope. Yeah, this is speaking in analogies. You're going to create a secret on a piece of paper, and then you're going to seal it inside of an envelope. Then you're going to hand that to the bank, and the bank is going to sign on the outside of the envelope, and the signature will be pressed in onto the note. So yeah, you take a secret, you seal it up in an envelope, you pass the sealed envelope to the signer signs the envelope, and returns the signed envelope to the user, and now the user has a signed secret that the signer never actually personally saw. So they can authorize data without actually reading it. Yeah, so the result is that you can verify and authorize data without ever seeing it. Yeah, this sounds like magic, but this is a well-known cryptographic primitive invented in the 80s by David Chaum. Are there any questions about this specific concept? This is important for understanding the crux of everything we talk about. Yes? Yeah, how do you verify with something without looking at it? The thing that's actually being signed is only the extra data, or actually, great question. You have a different set of signing keys for every kind of data that you're signing. So so in practice, we'll have a different set of key, or a different key to sign notes worth like 1 Satoshi, 2 Satoshis, 4 Satoshis, etc. So it's trivial to know what the data is representing when you have a different signature for each. Yeah. Cool. All right, so how does our bank work when we are signing, when we're using Chaumian ecash, using the same example as before? Well, Alice is going to give the bank $10 of Bitcoin, or it's just $10 generally, and an unsigned blinded ecash note. So Alice is going to have some money and generate a secret and seal that secret inside of an envelope and hand it to the bank. Next, the bank is going to, one, verify that the money is valid, and then the bank is going to sign on the outside of that sealed envelope and return the sealed envelope to Alice. So bank returns the blinded ecash note, the signed blinded ecash note to Alice. And then she can open up the envelope and see the valid signature inside of it. Now, Alice has a blinded signed ecash note. How does a payment work? Well, Alice just gives Bob a copy of the signed notes. This is, again, a secret with a valid signature from the bank that the bank has not seen. Now, Bob, upon receiving the signed notes, Bob can send this back to the bank. It's now unblinded, but Bob is going to send it back to the bank, and the bank is going to do two things. First, it's going to verify that the signature is valid, which it can do trivially. And second, it's going to verify that the bank has not seen this note already. So one important note is that, at this point, has the bank ever seen the data that has the signature? No, it hasn't. So the first time that the bank sees the value, the corresponding value of the blindedly signed note is when Bob goes to redeem that ecash. Okay, so Bob is going to send the note to the bank. The bank is going to verify, again, that the signature is valid and the note hasn't already been redeemed. Then Bob is going to go through the same issuance flow of ecash to get another new ecash note worth the same amount of money. So Bob is going to generate a secret, seal it in an envelope, send it to the bank. The bank is going to sign on the outside of the envelope, return the sealed envelope that has a signature on it to Bob, and then Bob can unblind it, can take the new message out of the envelope that has a new signature. So this is how ecash payments work. Cool. Any questions? Following? Yes? Yeah? Cool. Yes? No, so the bank just sees this as any other ecash note. This is a great question. This is a core concept of ecash that gives it its privacy properties, is that there is no connection between Alice's note and this new note, other than it's the same value. But the bank has not seen this specific signature. The bank has signed many notes of the same denomination, and it has not seen the contents of the note until Bob goes and redeems it. So the first time the bank sees Bob's note is when Bob is redeeming it, and they have no idea which blinded note corresponds to the unblinded note. Yeah, so there's no connection, but the bank can't connect what they actually wrote on the paper and what they see in the unblinded note, but they can verify that it's valid. So they know that they signed it, but they have no idea when they signed it or on which blinded note that they signed. Cool. Yes? Correct. Correct. It's blinded at that point, yes? Sorry, how does the bank know what? Yeah, so the bank signs different sized notes with different keys. So they can verify that a signature was produced with a single key, with a specific key. And then that's like the 1 sat key or the 2 sat key or the 4 sat key. Yeah, so they just verified the signature. So the signature just won't be valid if they use a different key. It would only be valid for one specific key. Yeah, that's how it works. Yeah, when you tell the bank, okay, this is a signature for this specific denomination, and then they only check that one key. And if it's not valid, then they reject it. Cool. All good? All right, so this is Chaumian ecash. We have a digital money, and it works just like cash. What I'm trying to draw the connection with is that this looks a lot like what banks looked like before we had digital banks. This process works just like a normal bank would work if you're only using paper money. And we have achieved what we call near perfect privacy. In this system, there's no linkability from the payments. So the anonymity set is equal to all of the users in the system. There's no traceability. So we have a near perfect private payment system. What's the problem? Yes. You could argue that denominations. Yeah, so you know that the anonymity set is limited to the number of people that are using the same sized notes as you. Technically, it's not a zero knowledge proof algorithm, so there's some data that you're leaking. Yeah, there's other ways to go. But for all intents and purposes, it's basically perfect. Yeah, just to be specific, it's near perfect, but just for all intents and purposes, it's as good as you'll ever need. Cool, thank you. So what's the problem in this system? Can anybody guess? Well, the amounts, but okay, the one I want to talk about is we're still using fiat money in this world. You still have a central bank that you're trusting not to mess with the monetary policy. This is a picture of Venezuela. So the Venezuela bolivar was inflated away. It was hyperinflated away. It took a wheelbarrow to buy full of money to buy a loaf of bread. So yeah, the system is still reliant upon the quicksand that is fiat money. So in 1998, DigiCash goes bankrupt for a variety of reasons. Calais, the author of these tweets, is also the author of one of Bitcoin's ecash protocols. He has these tweets that I think sum this up pretty well. Bitcoin doesn't need ecash. Ecash needs Bitcoin. For decades, people have been trying to build an ecash system that catches on. It turns out you can achieve a lot more if you build on top of Bitcoin as an open monetary system that allows for permissionless innovation. It's like imagine building an ecash system like Cashew on top of fiat banks. Useless friction at every step. Yeah, also your money gets inflated away. So yeah, Bitcoin or ecash needs Bitcoin, not the other way around. Okay, part 2, ecash plus Bitcoin. Let's talk about Fedimint and building ecash systems on top of Bitcoin. First, Bitcoin in 2008, Satoshi releases a white paper, and he describes a solution for digital money that doesn't rely on any intermediaries. He makes a new money that uses a decentralized peer-to-peer public ledger. It's amazing. Wow, look how awesome Bitcoin is. Bitcoin has some incredible money properties, something that innovates on gold for the first time. It's censorship resistant, irreversible transactions, it's globally accessible, trustless, and it's verifiable. So yes, and the massive number of nodes inside of Bitcoin removes any single point of failure, which is spectacular. Bitcoin isn't perfect. It's got some issues, some things that we're all in this room trying to work out. One is that Bitcoin is slow. 30 minutes for a transaction to settle is far too long for a modern world. Another one is too expensive. Yeah, even though on-chain fees are low right now, it's still something like 50 cents to have a high priority transaction, which is too high for a cup of coffee. And lastly, it's too small. 7 transactions per second isn't good enough. So even though we have Bitcoin and it solves all of the money property problems, it's still not useful enough for replacing fiat money. And the last thing is Bitcoin's terrible for privacy. As we all know, we care deeply about fixing these problems. So let's try to fix Bitcoin in one fell swoop. Well, what can we use? Well, we have this innovation called banks. Banks solved a lot of problems for money back in the day. So here's the basic concept. Users are going to deposit Bitcoin into a bank. The banks are going to protect the Bitcoin and give vouchers back to the user to transact in their daily lives. So we have Chaumian ecash signing. So this is the same example. How would a payment work in this Bitcoin bank world? Well, first, Alice is going to give the bank 1,000 sats plus an unblinded ecash note. Yeah, this is going to look a lot like the ecash example we looked at already. So Alice is going to give the unblinded ecash note, or an unsigned blinded ecash note to the bank. That's sealed up. The bank is going to sign on the outside of the envelope, return the blinded ecash note. Alice is going to unwrap that note. Now she has a voucher worth that 1,000 sats. Next, she's going to hand Bob a copy of this signed note, and Bob is going to immediately send that to the bank. The bank can verify that the signature is valid and the note hasn't already been redeemed, so this is a new note. And then Bob is going to go through this reissuance process for to get a new note worth the same amount of money. Incredible. But yeah, so the bank, Bob is going to reissue the note or just withdraw from the bank. So if Bob withdraws, it's the same process. The bank verifies that the note is real and then just sends him Bitcoin instead of sending him a new note. Cool. So we have a Bitcoin bank. Can anybody think of the problem with putting all of our money in a bank and all of our Bitcoin in one nice pot? Single point of failure, yeah. If our server goes down, all of our money's gone. If one server gets hacked, then all of our funds are gone. It's going to be hard to trust putting all of our hard money under one roof. So is there anything we can do to improve this single point of failure problem? Well, what if we didn't just trust a single bank? We could spread out risk amongst a bunch of different banks. So that an attacker would have to take down multiple different endpoints, or you'd have to have a cascading multi-tier failure, not just a single point of failure. So this is the core of Fedimint. Fedimint is a federated ecash mint trying to be a Bitcoin bank without a single point of failure. Fedimint, the federated Chaumian ecash mint for Bitcoin. Fedimint supports a ton of awesome features, like it supports on-chain natively. It has the innovated custody solution. It's a distributed custody solution. It's privacy by default. It has Lightning support out of the box, built-in backup recovery mechanisms for your ecash. It's fully auditable reserves. You can see exactly all the money that's inside of the bank. Wow, it's amazing. Look at all the features. It's so spectacular. This is Fedimint. We're about to go into more of a technical deep dive, and we're going to actually build a wallet from scratch using vibe coding tools. So before we get there, just a quick distinction. There are two main architectural components in the Fedimint stack. The first is the servers. This runs a piece of software called Fedimint D. This is the banking software. This audits or keep tracks of the ecash notes. It verifies the signatures and it issues the money. It issues the notes and it holds the money. Then there is the user-facing software. The user software, the client software, holds the ecash balance and communicates with the guardians only when they're making payments. Specifically when you receive payments. Before the past, Fedimint's been around for about 3 years. Fedimint had a reputation for being hard to work with. It still carries this reputation. The Fedimint is complex and challenging to work with. So over the past couple years, we put tremendous effort into our development kits to make this actually an approachable, accessible experience for application developers. So we have the Fedimint SDK, which is a TypeScript library that takes the Fedimint client in Rust and puts it into a WASM module, so you can just use something that would be very familiar to you as a JavaScript developer. It works with WASM, but also we're working on React Native, so you should be able to use Fedimint out of the box and build a wallet. Any questions about Fedimint's architecture or what Fedimint is as a protocol? Cool. Yeah? Yeah, so it uses a consensus algorithm. So the Bitcoin is in a multisig. It's just like normal multisig. But all of the ecash is also federated. So you can trust the multisig threshold even just for ecash issuances. And it runs a consensus algorithm between the guardians. Yeah, we can go more into this if you want to later, but deep topic. Cool. So let's build a Fedimint client using the Fedimint SDK. Yeah, again, this is something we launched about 1.5 years ago. The Fedimint SDK is a toolkit to build ecash into apps. You can check out our documentation at sdk.fedimint.org. The mission of the Fedimint SDK is to provide the best possible developer experience for building with Bitcoin, full stop. Not just for building with ecash, but for building with Bitcoin. We want to lower the barrier to entry for creating safe, robust, and privacy-centric applications. Yeah, the thesis being that if the easiest toolkit has privacy involved, then hopefully as more apps start to flourish, they'll be using a privacy-enabled technology by default. So the library has several components. It is WebAssembly powered, so it ships the Fedimint client written in Rust into a WASM module that's lazy loaded into a web worker. We have Lightning and ecash payments out of the box, which means that you can have Lightning in day one without ever opening channels to your users. One of the hard parts about ecash wallets is state management. It's just making sure that you don't accidentally lose ecash for the user, because that ecash is the money. So we handle that for you. And lastly, it's framework agnostic, so you can use it in any web framework. All right. OK, we have about 30 minutes left. Right, we have about 30 minutes left. Let's build a wallet together, maybe in the next 20 minutes. So yeah, this is a workshop initially intended to be able to be followed along. It's going to be too fast to follow along. You're welcome to try. But I suggest just watching, holding on for the ride, and then if you're interested to build a wallet afterwards, you can watch the video and look at the slides. So we're going to create a wallet UI using AI tools. We're going to add the Fedimint SDK, and we're going to make it all work and send and receive money from a Fedimint wallet in the browser. So if you want to follow along, you can go to bit.ly/sdk-workshop-repo, and that'll be the GitHub repo. But yes, again, don't follow along now. Just use the repo. Cool. So our to-dos. We're going to make a wallet that looks kind of like Albi. It's going to have a balance, and we're going to be able to send and receive over Lightning. So to start, you can clone the repo. You would run git clone this Fedimint SDK workshop repo, and then run pnpmi. So I have cursor open. Let's see. This is the example project. We have everything working. Yeah, so this just uninstalled the dependencies that I had already installed. But yeah, so if we run this now, we should be able to see. Let's not use the cursor browser. Let's use an external browser. Yeah, so it's just a Hello World project. All right. So we ran pnpm-dev. We can see Hello World. Next is getting started. So on the Fedimint SDK documentation, there's a nice little getting started guide. And we can see how to make our first application. You're going to want to scroll past the create script and go to manual installation. The first thing we're going to do is run pnpm add, or you can use npm yarn. I like pnpm. We can install a couple of libraries. There's Fedimint core, which contains the TypeScript interfaces, and then there's transport web. So the idea being is that you can have the same interface if you're on React Native, but all of the web-specific stuff is inside of this transport web package, like all of the WASM. And if you were using React Native, it would be a different package. So let's grab this right here. We're going to install this package. And then we are moving right along. So the next thing we're going to do is update our vitconfig.ts. So we're using a technology called Vite in this repo. So we have a bunch of different frameworks with different tutorials. So yeah, with Vite, we need to update a couple of things in our config. So we're going to use pnpm to add Vite plugin WASM to our project. And then we're going to add a couple of things to our Vite config TS. So yeah, just configuration stuff. We're going to add this vite plugin WASM. This makes WASM work in our project. Then we're going to add this WASM plugin to plugins. Then we're going to add this worker section and optimize depths as well. Yeah, we don't need top level awaits, but we need everything else. Yeah, this is just boilerplate stuff, or boilerplate things. Cool. And if we did everything correctly, we should have, or let's use that one. We should have no errors running. We are looking good. All right. Next, we're going to create a Fedimint wallet. So there is some code in the comments of the slides, which you'll be able to look at when you're making your own wallets. So first thing, we're going to instantiate a wallet. So let's go to wallet.ts, or that file doesn't exist yet. So we're going to go to wallet.ts, and we're going to paste in this code. So this pulls in something called the wallet director. This is just the interface to create and deal with wallets. You can have multiple wallets if you want. So we're just going to be creating one wallet. Next, we're going to be pulling in the WASM worker transport. This is the thing that handles all of the web things. We're going to instantiate a director. We're going to set log level to debug. That just gives us better logs in the console. We're going to initialize the director, create a new mnemonic, and then we're going to create a new wallet. Just for testing purposes, we're going to attach this wallet to global this, and then export this wallet to be used in our application. So yeah, there's a few different things going on, but it's all boilerplate things. Yeah, we're going to try to make a seed. If we've already have a seed, it'll just no op. Cool. Yeah, feel free to shout out questions if you don't understand this code. But yeah. Following along? Yeah? Cool. Let's see what this looks like. So in the browser, we have this code running. Let's refresh and see what happens. So we should have something called wallet now. Oh, no, we haven't imported this yet. If we just do here, import wallet from wallet, console.log wallet, this will now actually run that code. So now we can see that the WASM is being instantiated. We can call wallets, and we have all of these different functions to call. So we do wallet.balance, for instance, .get balance, and this should return. Okay, cool. It says error client not found. That's fine. We haven't yet opened our wallet, so that's all good. But cool, we now have a wallet and working in the browser. What's next? Next, we're going to create all of the UI for our wallet using this one prompt. Yeah, AI tools are amazing. I've been using Cursor as my daily driver for a couple of years now. This is a prompt that makes an entire wallet. So the prompt is, I want to create a UI for a basic wallet app. The app should use React plus Vite, which is just the technologies we're using. And it should have a balance, a send button, which opens a simple form with one string field called invoice, and a receive button, which opens a simple form with one number field called amount. So let's see if Cursor is able to, well, what model should we use? Opus 4.5? Yeah? Sorry? Yeah, it's fine. Cool, let's see it work. What? Yeah, so we have not yet written the code for joining a federation. We will do that then. What are you guys using these days for making for vibe coding? Are you guys still using? Sorry. GLM? What's GLM? Oh, cool. Okay, I've not heard of it. Okay, let's watch it cook. It's making a lot of changes. Any others? I'm still using Opus 4.5. If there's something really hard, I'll use Codex now. I still think it'll think for a super long time and then get back with like a correct solution rather than just like outputting a bunch of code. But yeah, Opus still seems like the GOAT. Yeah, no, good question. Usually it doesn't, but that's fine. It's an easy change to make. Yeah. Yeah, great question. We cannot deplatform a mint. Yeah, so yes, anybody can create a mint. There is a reputation system that people have started making on Nostr for like posting mint reviews. Like this is trivially gameable, but like it's working pretty well now for just yeah, trying to, if you want to advertise that a mint has gone offline, then or that a mint is malicious, you can just publish it on Nostr saying don't trust this mint, it's terrible. And yeah, there have been a few mints to shut down, and this has been helpful. So yes, there is no way it's permissionless. There's nothing we can do to deplatform people, unfortunately. Or I guess fortunately. Cool. Let's see what it's cooked up. Oh, well, that's nice. We have a wallet. We have a send button with a single field called invoice. Oh, I even got the Lightning invoice prefix. That's kind of cool. And we have a receive button with amounts. Oh, even sat. So it actually got the fact that this was Lightning already. That's kind of crazy. Sweet. So our UI is done. Let's just keep all YOLO. All right. The next step we're going to do is write the code for opening the wallet. This is where we're going to join the federation if we haven't already. If we've already joined a federation and we have some wallet state stored in the browser, then we're just going to use that instead. So we're going to try to open the wallet with existing state, and if that fails, then we're going to open the wallet, or we're going to join a federation. So we can do that. This federation is a testnet federation, just so we can use a faucet, but this would work the same way by just swapping this federation invite with a mainnet federation. So let's see if this worked. We go here. Now we can see if wallet.is open. And this should return true now. Hey, we have an open wallet. Great. Next, let's subscribe to the balance. So right now, the number that you see on screen is just 0. The Fedimint SDK provides a nice little handler for you to subscribe to balance updates. Typically, it's an annoying process when you're building a wallet to like refresh the balance, and you always forget to refresh. So it's nice you can just subscribe to balance updates, and it'll magically stay up to date. So let's add in our balance updates. We are going to add a new state variable. There is already a balance, but we're going to add a set balance as well. And we are going to, convert. So Fedimint works with millisatoshis under the hood, so we're going to convert that back to sats and then set the balance. And now, oh, we already have money in this wallet. That's nice. Yeah, we have money from a previous thing. Okay, I'm going to delete this money just so it's easier. So under the hood, we're using something called OPFS for the database. So we're going to delete this. This is not going to work while this is running because there's a lock on the database. But if we just kill this and then refresh, now we should be able to delete this. Confirm, refresh. Come on. Yeah, it is protecting my Bitcoin. And our money is still there. Oh, that's great. Yeah, we did intentionally make it hard to delete your money on accident. But let's try again. We're here. We're going to go into OPFS. That is not here. Where is OPFS? That is awesome. Is OPFS not loading because it's not a real tab? OPFS Explorer, we're going to confirm, we're going to kill this. It's like so hard, yeah, well this is like edit the save, it's empty, but it's still there. It's like it's not working if there's not a site attached. Oh, what can I do? Okay, I can go to the wallet and I can just not instantiate the wallet. How about that? Yeah, it's testnet money. So we're just going to not instantiate the wallet. This is going to crash the site because, yeah, so this is not going to load the site, but it's still going to work. So now we should be able to, there we go. Cool, mission accomplished. We successfully deleted our money. Now, when we refresh, cool, now we have $0. Fantastic. We've fixed that terrible, terrible problem of having too much money. Cool, so these balance updates are now real. We now truly have 0 sats in this wallet. Let's figure out how to receive money into the wallet. First, we're going to create invoices. So we have this handle receive function. Let's go back to app tsx. We have handle open receive, and then we also have this handle receive function stubbed out already for us. So let's just take this code, or this is basically the same thing, so I think I can just delete this one. Or we want to grab the handle close dialog that it made. And we're going to want to have a new state variable that tracks this generated invoice. So we're going to have generated invoice and set generated invoice, and let's quickly, no, we shouldn't need this anymore, but we should, let's just display the invoice when it's generated. So on the handle receive modal, so we have the receive dialog, let's just stick this invoice in somewhere, yeah. So how about that, generated invoice, and cool. That looks good. Let's see if this works. We just have to do that, and this. All right, let's see if we can receive money now. So let's request for 100 sats, and then this is closing when we hit generate. So let's go back to our handler. So when we handle open receive, or handle receive here, we should not close the dialog immediately. We should allow it to stay open. Hey, there it is. So we can generate invoices. Hit generate invoice, we can see messages going back and forth between the WASM, and then when it's generated, we should, is this the same invoice? Changing? Yep, it's changing. Okay, so yeah, so we hit generate invoice, an invoice is generated, and we have this invoice to pay right here. So we can copy that, and now we can go to the faucet. So there's a faucet that Fedi runs called alpha.fedi.xyz. We can request money from this invoice. So I'm going to hit receive, then flip back so we can see it get received. And magically, this balance should get updated as soon as the payment settles, assuming that the payment settles. Assuming that the payment settles. Oh, there it goes, right when I flipped it. So cool, now we have money in the wallet. Pretty neat. Yeah, if you've ever built a Lightning wallet by hand, this would have taken hours before. It's really, really annoying to work with the Lightning. Imagine opening channels and all that stuff. But the fact that you can just add a few lines of code and receive money into a Lightning wallet out of the box and have all the privacy attached is pretty cool, I think. All right, what's next? Let's work on sending money. So sending is much easier. All we have to do is call wallet.lightning.pay invoice, and this should pay any invoice that we paste in. So let's go back. So we have this handle send function. The only difference is this one is very similar. So let's just grab this one line of code and stick it in there. And we also have to make this an async function. Let's just console.log the results. And this should be all that is needed for paying invoices. So now we can go back to our site. We refresh, we can see the money pop back up. We can go back to our faucet and let's say generate an invoice for 1 sat. We can copy that invoice and let's try to send money. So this is a test net, that's why it's LNTB, it's a testnet invoice. We should be able to send this, and boom, we've sent a single millisatoshi. It's kind of cool. Yeah, I guess we only generate 1 sat, or we're doing the conversion wrong somewhere. We said 1 sat. No, this was 1 millisat. Or maybe it is sats. We're setting the balance from msats to sats. And when we generate an invoice, we handle receive, we're taking amount sats, and this amount is amount m sats. Yeah, so we take the amount, multiply by 1,000. Yeah, and the balance that we return, updating the balance, is balance m sats. Get back to sats. Oh, are we? No. Amount sats. Parse into amounts. I'm not sure. Okay. It's hard to debug math on stage. Anywho, so we have a wallet that we can send and receive money to in the browser with just a few lines of code. Any questions about any of the code that we wrote? Was it all followable for software engineers in the room? Yeah? Yeah, it also supports on-chain, so not a part of the demo, but I can show you just in the console, we have this wallet object, so we can do wallet dot, what is it? Wallet, yeah. Wallet dot send on-chain. So yeah, we can send on-chain or receive on-chain. Yep. If we want to do ecash, we can do wallet dot mint dot, what is it? Dot spend notes. And then do something that we've done before. And then this is going to paste in or return ecash that we can then spend. Data, yeah, so this is a raw ecash node. So I could send you this long string over text, and then you could paste this into your wallet, and we can receive and send money offline. So yeah, it all works out of the box. Any other questions? Yeah, that I'm not sure if this. So this was something that we added somewhat recently, is like the backup recovery flow into the SDK. But that would be under wallet.recovery. Is it there? It is still unimplemented in this version. This is unreleased. I merged the PR like a couple weeks ago. Yep. Cool. All right. Well, congratulations, everybody. We just made a Fedimint wallet in like 20 minutes or so. It's pretty cool. And now you can too. Yeah, no, I think this is super exciting that we now have tools that are easy to use, that are very privacy conscious, or that allow you to make very privacy conscious applications. Yeah, hoping that privacy tooling just becomes the default. I'm concerned that if the tools that end up proliferating don't have privacy by default, we'll never get there. We'll get stuck with something that's not private. So happy that we have more tooling that's privacy centric. Yeah, the result is that now the easiest way to make a Bitcoin wallet, I think, arguably, is with Fedimint. This is a complete 180 from where we were a couple of years ago. But now, with these tools, you can make a Bitcoin wallet easier than any other tech stack. And it's using Fedimint, one of the most complex things we got. So with 30-ish lines of code, your wallet just works. Before Fedimint SDK, life was terrible. After the Fedimint SDK, life is amazing. Yeah, so the Fedimint SDK is a phenomenal place for new free and open source contributors. If you're interested in contributing to Bitcoin, this is something that's safe. We're just wrapping the functions created in Rust. So if, yeah, I think the Fedimint SDK is a phenomenal place for new contributors. If you want to work on a super cool project, you can get started by going to chat.fedimint.org or check out our docs at sdk.fedimint.org. PR's welcome. We had a couple of summer Bitcoin students this summer, and we have a couple of BitShala interns continuing to work on this project. Yeah, again, one thing that we're working on these days is making the project work for React Native. So yeah, we're very, very excited about the React Native development and have mobile wallets using Fedimint. Yeah, PR's welcome. Cool, that's all I have. Thank you. Yeah, any other questions? Or Lloyd?
Oh, questions? So I only came in at the end, but I basically got the gist of the Fedimint SDK. What if I'm just really good at Rust and stuff and don't care about the SDK stuff? Can I also do that, or is that really not the way to do it?
Yeah, so this is how, this was the only way maybe 2 years ago to build a Fedimint wallet is to use the Fedimint client crates. And you could, if you're familiar with Rust, then skip all of the stuff that we do for you to put batteries in it. Yes, you can use it yourself. Yeah.
Is it okay, or is it there like a lot of things I would have to do myself if I don't use the SDK?
No, I mean, there's careful, well, actually, yeah, so one thing you'll have to manage the bundling into like the final application. Like it's not easy to build like end user applications in Rust. So that's a hard thing. It manages your database for you, so you don't have to touch database things. It manages your networking for you to communicate with servers. So honestly, the hard Rust things are batteries included with the Fedimint, just Rust crate. But yeah, just the application-specific things like bundling are not included.
Any other questions?
Cool. Thanks for being here. Oh yeah. Yeah, join the dev call. There's a contributing guide. Yeah, thanks so much. Cool. Yep, that's it.